All right, so this is one of my favorite things, which means you'll hate it. If you're willing to memorize and you have some number sense, it's pretty easy. But you have to memorize. You've got to memorize these patterns. Now, this is what we call a difference of two squares, because you have two things that are squared and there's a subtraction sign between them. Since 25 is what's squared, A is 25, and B is 16 because it's also square. Notice it's not negative. I just have to follow this pattern over here. 25 minus 16, and then 25 plus 16. Now, I know kids are like, well, that's weird. Is it right? You know, in a time before calculators, this was a big deal for certain things because, 25 squared minus 16 squared by hand going to take people a while. It's 369. But 25 minus 16 is 9, and 25 plus 16 is 41. By gosh, they're the same thing. And this is non-calculator stuff right here. That's what this is, non-calculator. This is the part of the EOC where you don't have a calculator at your disposal. All right, here we have a cube, we have a cube, we have a minus. We're looking at this pattern right here. A is 12 and B is 8. So 12 minus 8. And we're supposed to do 12 squared plus because there's a plus. 12 times 8 and then plus 8 squared. And you guys can do 3. Factoring and solving, I love this stuff. And I'll do 5, because it's got a little hint there. Factor out that -5 first. You do that because that makes the z cubed factor positive. And 5 enters 320 a certain number of times. I believe it's 64. And you pulled the negativity, right? So now it's a minus. All right, so when I look at this thing, I see a z that's cubed, take away a 4 that's cubed. So I'm thinking about the a cubed minus b cubed pattern, which is a minus b times a squared plus ab plus b squared. You have that acronym SOAP. Same, opposite, always positive. All right, same, opposite, always positive. So anyways, looking at it like this, I see that A is Z and B is 4. It's not -4, it's +4, and I just plug into my little formula right here. Still have the -5. This has to be A minus B, so Z minus 4. Here I'm supposed to take my Z and I'm supposed to square it. Plus, because there's a plus, I'm supposed to do 4 times Z, or Z times 4, whatever you want. It is technically Z times 4. Plus 4 squared. And we're going to keep going. We have -5, Z minus 4. This cleans up to be Z squared plus 4Z plus 16. Now, I'm only asking about the real solutions. I'm not asking about all the solutions here. I'm only asking about the real solutions. This piece right here, right there, is always imaginary solutions. Always. It's the only piece that matters is the front piece, that guy right there. It is the only things that matter. So Z minus 4 must equal 0. So Z is 4. And you are supposed to factor these. They are factoring problems. All right, there's 5. I'll do this one because it's a sum pattern. So I happen to know that 5n cubed is 125n cubed. So A is 5n. I know that's going to be hard for some kids. I know it's going to be hard. If you want to take the cubic root of something in a calculator, you raise it to the 1/3 power. And you get a 5. Every TI-84, whether it's 20 years old or it's brand new, They all can do that. There's shortcuts on some of the newer faceplates. 216. What do you think that is? I believe it's 6. All right. So B is 6. So this is a plus sign. I have a 5n cubed plus a 6 cubed. I'm going to follow the a cubed plus b cubed pattern. Do you remember SOAP? Same, a plus b, a squared, opposite of a plus is a minus, a times b, always positive, plus b squared. And I'm going to plug stuff in. This is 5n plus a 6. Here we have a 5n that's squared. Think about 5n squared. It's 25n squared. Cannot write. 25n squared minus 5n times 6, 30n, plus 6 squared, 36. And we're equal to a 0. And the only piece that matters here, again, is this piece. Because why? Why is this piece the only piece that matters? Because this is, what is it? It's imaginary. There's nothing real there. So the only factor I care about is 5n plus 6. She's equal to a 0. It's a two-stepper. Subtract 6, then divide by 5, and n is negative 6/5. All right, what else is interesting up here? Probably 9. 9's different. I know some of us are really struggling on factoring, and then we change the exponent to a 4. 9 is not a quadratic, but it still factors. It's a trinomial, and it's still going to factor with a double set of parentheses. And let's see how she factors. To make an s to the 4th, it's going to be an s squared times an s squared because we add exponents. 2 plus 2 is 4. Takes a 3s squared and another s squared to make 3s to the 4th. Factors of 24 are probably 6 and 4. But not in this case. 8 and 3 is your pair. Because the outside's going to make 9s squared, and the inside's going to make 8s squared. And if the 9 was negative and the 8 was positive, I'd be in business. Now, wouldn't I? All right, now you get to use a ZPP. So you have two choices here. ZPP stands for zero product property. 3s squared plus 8 is 0. 3s squared is negative 8. And remember, I only wanted real solutions. This is imaginary. S squared is negative 8/3. I'm going to do it anyways, just because you need to see how this goes. So S is going to be plus or minus the imaginary root of 8 over a root of 3. Root of 8 is root 4 times root 2, which is 2 root 2. And I'm looking at this, plus or minus 2i root 2 over root 3. And I'm not permitted to have a radical in the denominator, so I multiply by root 3 over root 3. Now, root of 2 times root of 3 is root of 6, plus or minus 2i root 6, both pieces sitting pretty over 3. And again, this stuff is non-real. And I know you guys have the attention spans of goldfish. I only wanted real. I'm just showing you how you do it. So this is the one that matters. S squared minus 3 is 0. I add 3 to both sides. S squared is 3. There's two answers there. So S must be plus or minus a root of 3. Ta-da! Moving forward with our lives. What looks interesting here? A lot of them do. A lot of them do. Let's do this one. I'm quite certain I can pull a 32x from both pieces. And if I do that, I'll be left with x to the 4th minus 4. All right, I got my 32x. This is a difference of two squares patterns. X squared makes x to the 4th, plus or minus 2. Still equal to 0. Now I'm going to kick in the ZPP. Go away. I don't want you. How about you? Oh, that's what I press. All right, so by the ZPP, 32x is 0. Or x squared plus 2 is 0. Or x squared minus 2 is 0. Divide by 32, you know, God bless some of y'all, you do this. If I designed a TI-84, it would not answer this question. Because, you know, this shouldn't be something you're asking a calculator. It's 0. All right, this one, move your 2 over, and you get -2. And if you got to go another step, plus or minus root -2, that's non-real. Not interested. Add 2 to both sides. X squared is 2. Take the square root, plus or minus root 2, which, while funny, it's a decimal. It's 1.41 something. It's very much real. So your two answers that mattered were 0 and plus or minus root 2. Now, this was a 5, right? That means 5 solutions. You got 1 here, 2 there, that's 3, 2 imaginary, that's 5. Fundamental theorem of algebra to some degree. What's up with 13? 13 is a factoring by grouping technique. I noticed that both of these pieces have a c squared, so I'm going to pull that c squared. And it's not a solve because it's not equal to anything. It's also got 3 variables, so you can't really solve it. But if I pull a c squared from the first 2 pieces, and that's what I'm focusing my attention on, I will be left with a plus b. All right. Now, in order for this to work, a plus b has to repeat. And I made a mistake, didn't I? I did make a mistake. Where'd that 7 go? 7a plus b. And the 7a plus b has to repeat. Usually if you have 4 terms, it's factoring by grouping, and that's a b, it's not a 6. To make this piece right here positive, the negativity was pulled. To make that negative piece positive, the negative positivity was pulled. And the thing that was in common in both pieces was a d squared. So what do we have here? We have the common factor, which is 7a plus b, is common to both. And then we have the stuff left over, which is c squared minus d squared. And this is a factor completely. C squared minus d squared does, believe it or not, factor. To make a c squared, it takes a c and a c. To make a d, it takes a d and a d. And to cancel out to the nothing in the middle, positive, negative. I'm not going to do 14. I'll let you ask me how. I'm not going to do 15. That needs an A. Yeah, I'll do this one. Because it's inequalities, and kids don't like inequalities. The instructions are off to the side there. One-sider. Factor her. Let's see, a 5 and a 1 will do it because the outside is 15, the inside is 1. If that was negative 15 plus 1, we're in business. And what we actually have here are what we call critical values. Use that ZPP, negative 1/3. Another critical value is 5. And it talks about drawing a rough graph. I have less than equals, so solid dots. I know that looking at that, it opens up. It's an x squared, so it's a parabola. All right. Now, I talk about being greater than or equal to 0, which means touch or above the x-axis. And that is happening here and here. That's where it happens. Those pieces of the parabola are being created when x is less than or equal to a negative 1/3 or x is greater than or equal to a 5. So this, if we like set builder notation, remember set builder? All values of x such that x is less than or equal to negative 1/3, comma, x is greater or equal to 5. If we like interval, I'm running left to negative infinity, all the way to negative 1/3 with a bracket because we have equality, union with a bracket at 5, moving right until I hit infinity. And I did ask for intervals. I legit asked for intervals. Moving forward. Do that one. I'm not doing that one. Okay, so see this little guy right here? Rewrite the cubic root of x squared using the form x to the p over r is the rth root of x to the p. Exponents are coming. Be afraid. Exponents are coming. All right, so let's talk about this one. Let's talk about maybe something like this. What does 5, if I can talk. What does 5x to the 7/5 look like? So the 7 is the power, and the 5 is the root. And the understood multiplication between that 5 and the x, there's a multiplier that's understood to be there. We have to understand the understood. So the 5 has an understood exponent of 1. It's going to be outside of your radical. The radical has a root of 5. It's got a little 5 there. The x has a power of 7. You can write it like that. Just because, and it's kind of a big deal, believe it or not. It's one of these also understood things. If you talk about like something like 4x all to the half, all right? Root, power. We have a root of 2 with a 4x inside, and I don't need those parentheses anymore. With a 4x inside. Yeah, 4x inside. This is understood. It is understood. This is the root of 4x. And you can think of that as the root of 4 times the root of x, which is 2 root x. So hopefully that helps you do 19 and 20. Hopefully it helps. I don't want to do them. I'm going to leave them to you. I can't do all of it. You know, one of the things I feel that I don't do properly is I just don't let you practice enough on your own. I've got too many people who blindly copy, either off me or somebody who shares homework. And you're never going to get good at math unless you just sit down and practice it. There you go. There's your 3-3 stuff.